Hello students, in this video we are going to learn CET MCQ questions from 1 to 10. Read question number 1. The vapor pressure of given liquid solution will decrease. So vapor pressure of liquid directly proportional to temperature. So what does it mean? If temperature decreases, vapor pressure also decreases. So if you read all the options, you will get correct option is fourth one. If temperature decreases, vapor pressure also decreases. So question number 1, option 4 is the correct answer. Now coming to question number 2. Raoult's law is obeyed by each constituent of a binary liquid solution when. So remember, when Raoult's law is obeyed, that solution is called ideal solution. So in ideal solution, the intermolecular force of attraction between A and B, that is AB force of attraction, will be always identical to that of AA or what? BB forces of attraction. So if you read all the options, so you will get correct option as C. The force of attraction between like molecules, that is AA or BB, are identical with those between unlike molecules. Unlike molecules means A and B, that is AB force of attraction. So like molecules means either A or what? BB. So therefore, second question, third option is correct answer. Coming to question number 3. So they have given urea dissolved in water. So therefore, water is a solvent. Water is a solvent. Then urea is a solute. So what are the given things about water? Number of moles of water is given, that is N1, 9.9 mole. Then urea, they have given mass W2, 6 gram. And molar mass of urea is also given, that is M2, 60 gram per mole. If vapor pressure of pure water is P0, that is vapor pressure of solvent they have given as P0, what is the vapor pressure of the solution? So vapor pressure of the solution means you can write P1. P1 means vapor pressure of component 1 in the solution, that is vapor pressure of the solution. So first you find out Chi1, that is mole fraction of solvent. So that is given by the formula N1 by N1 plus N2. Here we don't know N2. That's why N2 means number of moles of solute. First you calculate that one. So formula for N2 is W2 by M2, that is 6 by 60. So you will get 0.1 mole. Now substitute here. So N1 is 9.9 divided by 9.9 plus N2 is 0.1. So you will get mole fraction of the solvent as 0.99. Now you can calculate mole fraction of solute, that is Chi2, using the formula 1 minus Chi1. So 1 minus 0.99, you will get 0.01. So now use the Raoult's law for RLVP. So Raoult's law for RLVP is nothing but RLVP, that is relative lowering of vapor pressure of liquid, is equal to Chi2. So now what is the RLVP formula? That is P01 minus P1 divided by P01, that is equal to Chi2. Now you cross multiply that. P01 minus P1 is equal to P01 into Chi2. Now you rearrange these two things. So you will get P1 is equal to P01 minus P01 Chi2. So take P01 common factor. P01 is nothing but 1 minus Chi2. So now you substitute P01 into 1 minus Chi2, that is 1 minus Chi2 value is 0.01. So you will get P01 into 1 minus 0.01 means 0.99. That means vapor pressure of the solution will be P1 will be P01 times of, P01 time 0.99 times of P01. So that is option D. So third question, option D is the correct answer. Now coming to question number 4. Calculate the weight of non-volatile solute having molecular weight 40, which should be dissolved in 57 gram of octane to reduce its vapor pressure 80%. That means if you read this question, non-volatile solute dissolved in 57 gram of water. So therefore, solvent, sorry, it is not water, octane, 57 gram of octane. So solvent will be octane. So you remember octane formula will be C8H18. Now the solute, they have not given the name, so it is unknown solute. So what are the given things? Mass of octane, that is solvent W1, 57 gram. So solute mass, that we have to find out, W2. So molar mass of solute M2 is given 40. So 40 gram per mole, that is molar mass. Then they have not mentioned name of solute, but they have given non-volatile solute. Therefore Van 't Hoff factor will be 1. Suppose if you assume vapor pressure of the pure octane, that is pure solvent, as P01. So what P01 represents? Vapor pressure of pure solvent, P01. Then you can find out molar mass of solvent, that is M1, using the molecular formula C8H18. So that will be 114 gram per mole. So now, in addition to that, they have given vapor pressure of reduces to 80%. That means about solution, remember vapor pressure of the solution will be 80%. 80% means for 100 it is 80. So we have assumed initial vapor pressure of solvent as P01. So therefore P01 initial. So 80% of initial, correct? 80% of initial means 80 by 100 times of initial is P01. So that will be vapor pressure of solution. I will call that as PS. That will be equal to 0.8 times of P01. So these are all the given information. So now I am going to use Raoult's law. So according to Raoult's law, RLVP, relative lowering of vapor pressure, is equal to mole fraction of solute. So relative lowering of vapor pressure can also be written like this, P01 minus, so instead of P1 you can write vapor pressure of solution divided by PS. So this is another way of writing Raoult's law. That will be equal to Chi2. Chi2 means number of moles of solute divided by total number of moles, N1 plus N2. Here, when compared to number of moles of solvent, in the denominator you can neglect number of moles of solute. So finally you left with N2 divided by N1. So what is N2? Number of moles of solute. So that is given by the formula mass of solute by molar mass of solute, that is W2 by M2. Similarly, N1 is given by the formula mass of solvent W1 by molecular mass of solvent M1. So finally, if you substitute those things, so you will get the final formula as P01 minus PS divided by PS is equal to W2 by M2 into M1 by W1. So now you substitute the values. So P01, that is vapor pressure of pure solvent, minus PS, vapor pressure of solution, is 0.8 times of P01 divided by again PS, that is 0.8 times of P01, that is equal to W2 divided by M2 into M1 by W1. So now in the numerator you take P01 as the common factor, you will get 1 minus 0.8 divided by 0.8 times of P01. So P01 cancels out. So W2, that means we have to find out mass of the solute. M1, that is molecular mass of the solvent, we have already calculated, 114 by molar mass of solute, they have given as 40 in the problem, into W1 means mass of the solvent, 57. So if you simplify this, on the left side what we are having, 0.2, 1 minus 0.8 is 0.2, that is equal to W2 into 114 by 40 into 57. So if you simplify, so you will get W2 as 5 gram. So 5 gram is there in option 2. So fourth question, second option is the correct answer. Now coming to question number 5, vapor pressure of pure benzene and toluene. That means they have given two liquids, one is benzene, another one is what, toluene. So I will consider benzene as component 1, toluene as component 2. So what are the information given about these things? So vapor pressure of the benzene, that is P01, is given 160 millimeter of mercury, 160 millimeter. Similarly, vapor pressure of toluene is also given, that is P02, that is 60 millimeter of mercury. Then equimolar solution, they have mentioned equimolar solution of benzene. That means equimolar means mole fraction of solvent. If you consider 0.5, so this mole fraction is also 0.5. So equimolar means chi1 plus chi2 will be always equal to 1, correct? So equal means chi1 should be 0.5, chi2 should be what? 0.5 only. Then you will get sum will be 1, correct? So that's why chi1 becomes 0.5, chi2 becomes what? 0.5. So now we are going to use the formula. What is that formula? P total, that is vapor pressure of the mixture. P total is nothing but P01 chi1 plus P02 chi2. That is Raoult's law, correct? So P01 is 160, chi1 is 0.5 plus P02 60 into 0.5. So you will get finally 110 millimeter of mercury. So this is P total. So now what they're asking mole fraction of benzene in vapor phase. So to calculate that, we have to use Raoult's law in vapor phase. So what is the Raoult's law in vapor phase? Partial vapor pressure of component 1. Component 1 means benzene is equal to P total into mole fraction of benzene, that is mole fraction of component 1 in vapor phase. Mole fraction of benzene in vapor phase means Y1. So they are asking Y1 here. Y1 is equal to P1 by P total. So P1 is nothing but P01 chi1 divided by P total. So P01 chi1 means 160 into 0.5 divided by total is 110. So you will get 0.727, approximately 0.73. So that is the mole fraction of benzene in vapor phase, that is Y1. So it is there in option number 4. So question number 5, fourth option is the correct answer. Now coming to question number 6. Which solution has highest vapor pressure? So remember, vapor pressure of liquid directly proportional to temperature. That means more temperature, more vapor pressure. So now you read all the options. In all the options, highest temperature is 50 degrees Celsius. Therefore, you can neglect second and fourth option. You have to consider only option A and C. So now in option A and C, temperature is same, 50 degree. So then we have to use one more concept, that is if product of Vanta factor, that is I, into C, concentration is less. If concentration of solute is less, then vapor pressure of that liquid will be more. So therefore, we have to calculate I into C in option A and C. So coming to option A, so NaCl is given. NaCl means 1 mole of sodium ion, 1 mole of chloride ion. So the Vanta factor value for NaCl will be 2. Then concentration is molarity is given 0.02. So if you multiply this, you will get the product as 0.04. Now coming to option C. So in option C, they have given calcium chloride, 1 mole of calcium, 2 mole of chloride you will get. That's why. So Vanta factor will be 3 for calcium. Concentration is 0.005. So if you simplify this, obviously this value will be very less, correct? 0.015 you will get. So this product I into C product will be less for option C, and temperature of course more, 50 degrees Celsius, correct? So more temperature, less IC means option number C. So question 6, option C is the correct answer. Coming to question number 7. So they have given two liquids A and B, and there of course vapor pressure will be given P naught A and P naught B. They are in the ratio 1:3. That means you can write like this: vapor pressure of P naught A ratio they have given means P naught B. So P naught A by P naught B will be 1/3. So 1:3 means 1/3. So this is the thing. So now I am going to assume P naught A, vapor pressure of liquid A, as P. Correct? So assume that P naught A is equal to P. So now you cross multiply these things. So what do you get? P naught B will be equal to 3 times of P naught A. Now 3 times of, I have assumed P naught A as P, that becomes 3 times of P. So P naught B becomes what? 3 times of P. So now you calculate mole fraction of component A. So formula, number of moles of A by total number of moles, that is Na by what? Nb. So number of moles of A is 1 because 1:3 they have given. So number of moles of A is 1 divided by 1 plus number of moles of B will be 3. So that will be 1/4. Similarly, you calculate mole fraction for component B. So formula, Nb by total number of moles, Na plus Nb. So that will be 3 by 1 plus 3. So that is 3/4. Now partial vapor pressure of A, that is Pa, is given by the formula P naught A into chi A. So P naught A we have assumed as P into chi A value is 1/4. So this will be P/4. Similarly, partial vapor pressure of component B is given by the formula P naught B into chi A. So P naught B we have calculated, that is 3 times of P into chi B. Chi B value will be 3/4. So if you simplify this, you will get 9 times of P/4. So now they're asking mole fraction of A in vapor phase. So mole fraction of A in vapor phase is Ya. So that is given by the formula partial vapor pressure of A, Pa divided by P total. So Pa means we have calculated, that is P/4. P total means you add these two things, that is Pa plus Pb. So you will get 10 P/4. 10 P/4. So further simplification, P/4 into 4 by 10P. 4 cancels out. PP cancels out. So you will get 1/10. So 1/10 means 0.1. So Ya means mole fraction of component A in vapor phase, that is 0.1. So 0.1 is there in option A. So question number 7, option A is the correct answer. Now coming to question number 8. Total vapor pressure of the mixture of 1 mole X, whose P naught X is given, and 2 mole Y, P naught Y is given, is 240. So what is the correct option? They have given 4 options. So here 2 liquids are given. One is X, another one is Y. For X, what are the given? Number of moles of X is given. So I will consider that as Nx, that is 1 mole. And vapor pressure of X, P naught X is given, that is 150. So similarly for Y, number of moles of Y is given as 2 moles, and its vapor pressure P naught Y is given 300. 300 they have given. In addition to that, total vapor pressure is given, that means P total. So I will consider this as total vapor pressure of the mixture. Mixture means solution. Experimental value they have given 240 tar. Now they're asking whether it shows negative deviation, positive deviation, like that. So to calculate, to identify that, we have to find out P total using Raoult's law. So before going to calculate P total from Raoult's law, first let us calculate mole fraction of X. Mole fraction of X means chi of X. The formula, number of moles of X by total number of moles, Nx plus Ny. So Nx is 1 divided by 1 plus 2. So that will be 1 by 3. That is mole fraction of X. Similarly, you calculate mole fraction of Y. Same type of formula, number of moles of Y by number of moles of X and number of moles of Y. So 2 by 1 plus 2, that is 2 by 3. So now you calculate P total using Raoult's law. I will consider as P total Raoult's. That is given by the formula P naught of X into chi of X plus P naught of Y into chi of Y. Now you substitute. P naught of X is given as 150 into mole fraction of X is 1 by 3 plus P naught of Y is 300, mole fraction of Y is 2 by 3. So after simplification, you will get 250 torr. So now this is the P total calculated using Raoult's law. So compare this value with the given P total. So what is the conclusion now? So P total calculated by Raoult's law is greater than P total given by conducting experiment, correct? So that means vapor pressure of the solution is lesser than that of Raoult's law. So what is that conclusion? This is vapor pressure of solution by experiment, correct? Vapor pressure of solution is lesser than the expected vapor pressure as calculated by the Raoult's law. So when it is lesser means the solution shows negative deviation from Raoult's law. So it shows negative deviation means correct option is option A. So 8th one, correct option is A. Coming to question number 9. So in this problem they have given bromoform has normal freezing point and its Kf value is given. A solution of 2.6 gram of an unknown, of course unknown solute they have to mention, unknown solute in 100 gram of bromoform. That means some solute is dissolved in bromoform. So therefore solvent will be bromoform. Solvent will be bromoform and solute they have not mentioned. Simply you take that as solute. So what are the given things? 100 gram of bromoform, that is W1 given. W1 means mass of solvent, that is 100 gram. Then similarly mass of solute is given 2.6 gram of unknown solute, correct? So W2 will be 2.6 gram. Then Kf value for the solvent is given, Kf value. So that is 14.4 degrees Celsius per mole. So no need to convert it into Kelvin. Whenever Kf is given, either it is in degrees Celsius or Kelvin, no need to convert. Okay. Then they have given normal freezing point of bromoform. That means freezing point of pure solvent T naught F is given 7.734 degrees Celsius. Then it freezes. So freezing point of the solution is given. Freezing point of solution means we consider that as TF. So you can write separately here solution. So freezing point of solution TF is given as how much? 5.43 degrees Celsius. Now what is the question? What is the molecular weight of the unknown solution? Molar mass of unknown solution is M2, that you have to calculate. So before going to calculate M2, first you calculate delta TF, that is depression in freezing point. So what is the formula? Freezing point of solvent T naught F minus freezing point of solution TF. So solvent is 7.734. So solution is 5.43. So we will get 2.304 degrees Celsius. So here also no need to convert this value into Kelvin because it is delta TF means difference in freezing point. So difference remains same whether it is in Kelvin or degree Celsius. So now use the formula to find out molar mass using freezing point concept, that is M2 is equal to I Van 't Hoff factor W2 by W1 into Kf by delta Tf into 1000. So this is the formula. So I means Van top factor. Here they have not mentioned anything about the solute. Therefore, Van top factor can be taken as 1. WO2 is mass of the solute, that is 2.60. WO1 mass of the solvent, that is 100. Kf value is given, that is 14.4. Depression in freezing point delta Tf is 2.304 into 1000. So after simplification, you will get molar mass of the solute as 162.5 gram per mole. So this is the answer. So question number 9, second option is correct. So 162.5, second option. Now coming to the last question of this video. C6H6 freezes at 5.5 degree. At what temperature will a solution of 10.44 gram of C4H10 in 200 gram of C6H6? That means C4H10 dissolved in C6H6. So therefore the solvent will be what? C6H6. Solute will be C4H10. So this is the information. Now solvent C6H6 is given as 200 gram. Therefore mass of solvent WO1 will be 200 gram and WO2 will be 10.44 gram. Then freezing point of what is that? C6H6 is given, that is considered as T0F, that is freezing point of solvent, 5.5 degrees Celsius. 5.5 degrees Celsius. Then Kf value is given for solvent, that is benzene, 5.12 degrees Celsius per molal. Okay. So WO2 on the other side solute, that is WO2 is given. You can calculate molar mass of solute M2 using the formula C4H10, that is 4 times of carbon 12 plus 10 times of our hydrogen atomic mass is 1. So that will be 58 gram per mole, that is the molar mass of solute. They are asking at what temperature will solution, that means freezing point of solution, that is TF. They are asking TF, you have to find out. Okay, solution. So now we are going to use the formula molar mass M2 is equal to I into WO2 by WO1 into Kf by delta Tf into 1000. So now using this, first you find out delta Tf. So delta Tf is equal to, after rearranging the formula, you will get I into WO2 into Kf into 1000 divided by WO1 into M2. Now you substitute the values. So of course solute is unknown solute and it is an hydrocarbon. So Van top factor will be 1. So WO2 value will be 10.44 into Kf is 5.12 into 1000 divided by WO1 is 200 into M2 is 58. So depression in freezing point, that is delta Tf, will comes out to be 4.68 degrees Celsius. So now they're asking what is that? Freezing point of the solution. To calculate the freezing point of solution, we are going to use the formula, that is depression in freezing point delta Tf is equal to freezing point of solvent minus freezing point of solution. So now we have to calculate freezing point of solution means, so you take Tf to the left side and delta Tf to the right side. So you will have Tf is equal to T0F minus delta Tf. So what is T0F? That is freezing point of solvent, 5.5 minus delta Tf, we got 4.68. So if you subtract, so you will get the freezing point of solution as 0.82 degrees Celsius. So 0.82 degrees Celsius is approximately there in option B. So option B, 10th question, second option is the correct answer.